Testing and integration is an important phase of software development lifecycle. It becomes more valuable when we are building software responsible for billions of dollars worth of transactions. If you are interested in learning about Ethereum blockchain network upgrade testing, stay with us. Welcome to PEEPanEIP episode 116. I am Pooja Ranjan from Ethereum Cat Herders, and today we will be talking about Dencun testing. As most of you may know, Dencun is the next planned Ethereum network upgrade. Currently, clients and testing teams are working on a developer's testnet, also known as Devnet, and the number is 8. To share more about Dencun testing, we are joined by Ethereum testing team, Parithosh Jayanthi, Mario Vega, and Barnabas Busa. Thank you all for joining us on PEEPanEIP.
Hey, thank you for having us.
Before we get into the talks of protocol testing, ETH deposit and validators, can we have a quick introduction for our new followers and may let them know about your journey with the Ethereum ecosystem?
I've joined the Ethereum Foundation 1 year ago, and I have joined just a couple of months before the merge has happened. I've been working in the sub-team of the DevOps team of the Ethereum Foundation called the PEEPanEIP, and they've been primarily responsible for testing all the features that are coming to the Ethereum as a whole. We have launched multiple testnets and devnets since. I was responsible for launching the visual testnet, and lately I've been working on the Dencun devnets and some other testing.
Hey, my name is Mario. I work for the testing team. I joined the EF 2 years ago now, and my main job is to basically write functional testing for all the updates and the upgrades that happen through the Ethereum forks that have happened. I joined before the merge and wrote tests for the execution clients, also the consensus clients on the merge and also on Shanghai and now on Cancun. I work mainly on the execution specs now, which is like the Python-based testing that we do for the EVM, and also a little bit of Hive, which is like the integration part of testing.
Hey, I'm Parithosh. I'm also on the same team as Barnabas, so the PEEPanEIP team. And most of the work we do revolves around coordination for testing. So knowing which tool affects what where and how we can most efficiently spin up testnets. And of late, we've been trying to refine a lot of our processes so that we can not only support one fork. So earlier we were just able to test the merge or test withdrawals, but nothing else. But now we've been working a lot with testing multiple forks, and I'm helping Barnabas and the other people in the team to achieve that.
That's awesome. Great to know all this information about Ethereum testing team. Just out of curiosity, before we move ahead, does this ETH team is for consensus layer or like we all work in sync?
We kind of inherited the panda meme from the merge. So it's the team that works between it's the DevOps team that works between the EL and CL.
Awesome. Very well.
Yeah.
All right. This is really great. And I hope it inspires someone to join the Ethereum ecosystem. Well, I'm aware of the presentation that we have here for today. So without further ado, let's peep in.
So I wanted to give you guys a brief introduction to where we are right now. So we have the withdrawals fork behind us. It seems to have gone really well, and the network has been stable for the last couple of months. And the next fork down the line is Cancun or Dencun. And we're working really hard with Dencun. And that's the testing team, the PEEPanEIP team, there's a bunch of client teams, etc. But Dencun comes with its own set of problems, which is it's a really, really big fork at this point. We're touching a ton of parts of Ethereum all at the same time. So we have 4844 that's going to bring in scaling. We have 2 to 3 new opcodes where we got the beacon block root in the EVM, which is also first time I think that we're doing a system transaction. And I know Mario will talk a bit more about that one. And we have the self-destruct deprecation. So with all of this, the scope of testing has just become really, really important. And today we want to give you a bit of an insight into what tools we're using to achieve this and how we're doing it. And at the same time, to try and give you a glimpse into how we're organizing ourselves to support more than one fork at one time. So today, right now, we are testing Goerli, we're testing Devnet, we're testing a bunch of feature forks. So we have this one EIP, I think 6110, which is deposit processing workflow changes. And we have a bunch of devnets for that. And I see Daplans on the call. So just last week, we launched tiny testnet with him about Whisk. So that's another upgrade coming up. So we have a feature fork for that. And we also have Goerli testing, and we will be having UF testing as well. And as you can see, this is very different structure from how we had in the past, where I think with the merge, for example, we had everyone's efforts focused on the merge. But right now we have a lot of small feature forks and everything needs to be tested well. So hopefully this talk gives you a bit of a glimpse into how that's going to be achieved. Yeah, so this is kind of a glimpse into our testing workflow. How do we try to bring order into chaos? So as with everything, we start with spec releases. So this is kind of the starting point when we're trying to get involved. Of course, there's the whole EIP process before that. There's a whole bunch of thought that has been put into stuff beforehand, but we try to get involved once it's at least considered stable enough that it's getting into the specs repo. And by the specs repo, I'm meaning more or less consensus layer specs repo. And from there, the client teams can start implementing the specification as defined there. And they would tend to do that either in a branch or a fork. So that was already kind of our first got you. You can't hard code any branch or any repository anywhere. You have to be able to dynamically build everything, to dynamically refer to everything actually. And one example of where we had to do this is client teams tend to build Docker images / releases just for their mainline / potentially an unstable release, but nothing else. So we had to set up our own builder system such that we can build each and every single client, irrespective of which fork or which branch it is. And that took a decent bit of time to actually get right. There was someone in the team who had to learn Bazel against their will. God bless that person. But it's working. We're using it stably. Once we know that we're targeting a certain branch or fork, we also add it to a config and it gets built every hour so that if there's a change, we're able to easily reference that change. And we also had to kind of standardize our naming scheme. So all the images we have a certain naming scheme, which tends to be branch/commit, so that at first glance, you already know what branch am I talking about, what commit am I on, and what issue do I have with that commit. That kind of makes it a lot easier for us to do things. Hive has a similar setup. So in Hive, you can specify a Docker file or you can specify client branch, and Hive will build it itself before running the whole slew of Hive tests. And Mario and his team is working a ton on Hive test upgrades. So it depends on which forks they're supporting at which time. But right now, a lot of their time is spent, for example, on Devnet tests because the spec is the most clear. It's the next fork. We need to have all hands on deck for that. Earlier, while Hive tests were still being worked on and while clients were failing Hive tests, we used to also spin up devnets at the same time. And with withdrawals, we kind of realized that's not the most efficient use of time or money because we were catching a lot of things that Hive had caught had someone been paying attention to Hive. So one thing we tried to enforce this time is we're not going to go ahead with devnets until people are passing Hive tests. So we kind of stalled Devnet progress until Hive was mostly green, or the failures were acceptable failures or known failures, or failures that we knew were non-trivial to fix. This already caught like a ton of, hey, do I have a certain engine API version up? Or will I be able to even accept this request? This takes care of a lot of base level problems that we were always watching on devnets. And one of the reasons we wanted to do this is our devnets are a high coordination issue. And it takes a bunch of time away from client devs to debug those devnets, as well as from everyone else to debug those devnets. Whereas Hive is a nice, clean package. You can download the logs, you know what you gave in, you know what you broke. So if we're able to take care of problems at the level of Hive, we want to, as much as possible. And once that's something we tried out this time, and I actually really like the approach. I think Devnet 8 launched not too long ago, and I know Barnabas is going to be talking about that. And one of the reasons we were so confident about its launch is because we kind of saw that a lot of issues were taken care of by Hive already. And what wasn't taken care of by Hive, we kind of used local testnets to figure it out this time. So local testnets, we're using a tool called Kurtosis to do this. It's implementing testnets in Starlark, and you define them in a simple JSON body. And Barnabas is also going to show you guys an example of this later on. But essentially what you can do is you can have a mini testnet, go through a certain fork and see how the network is going to react. And the reason we want to do this is not that Hive can't do interop testing, but we also want to do local interop testing. So we were able to spin up a testnet locally of every single client combination, for example, and we were able to already catch a bunch of low effort bugs there. For example, out of gets that is running with every one of the 5 CLs, one of them refuses to validate all the time. The network is 80% performant. And because there's just 5 nodes, it's very obvious which one is missing. And looking through the logs, it's very apparent as to what was missing. So, and we're able to take this Kurtosis JSON body and share it with the client teams. So it's also kind of a reproducible issue that everyone is going to face. So we were able to knock out a lot of problems in no time. And the Kurtosis testnets, you can also mess with the time, and you're basically doing it locally. So you're not dependent on anyone. So you can do 100 runs an hour if you want, and then just skip through a lot of the issues. And in our current workflow, we do this a bunch of times until we're happy with the result. And once we're happy with the result is when we commit to a full-fledged devnet. And the reason we want a full-fledged devnet is that client teams, there's some issues you just won't find with local devnets. So we want to have the full-fledged one. And you want community involvement, you want client team involvement, you want external people to sync up with it. You want a stable location where people who are building tooling will be able to sync to it, and so on. And you want to also test sync, which is a very big and important thing, right? So that's the kind of approach we took this time. And that's where we are right now with Devnet 8. And once we're happy with the stability of the devnets, we kind of promote them to attack nets. So think about Kiln as a network that we had, or Kintsugi as a network that we had. We had a bunch of devnets, and then we had these public big testnets. So we will be having that for Cancun as well. And these public testnets are also kind of viewed as attack nets. You unleash whatever you want on them, and technically they shouldn't break. And once we're happy with that stage, we graduate to Shadow Forks. And the reason we graduate to Shadow Forks is now you're simulating a real network load. You would be forking from mainnet, or you would be forking from Goerli or from Holesky. And this gives us an idea on how much computational resources are required for the new fork. And we're also able to call contracts that exist on mainnet, etc. So it's a really important test suite that we have. And finally, we move on to the actual public testnet. So Goerli, Sepolia, Holesky. And finally, we would announce a mainnet date. So this should give you kind of an idea of where we're going with testing itself. And the whole system is kind of built such that we can not only support the main fork, but also a bunch of feature forks without any delay. So with the feature fork, usually it stops at the devnet level until it gets included into kind of the next big Ethereum fork. And once it does, that's when we start giving it attack nets. That's when we start doing shadow forks and so on. So it's this approach of not stalling things until we actually have to, so that specs can be really cleaner. They can already go through a bunch of iterations before they're even committed to run on mainnet. So that's kind of the approach we're slowly converging on with this upgrade. And to give you an idea of what kind of tests we run, this is largely written with Cancun in mind, but of course will also apply to everything else. So we have a bunch of EVM changes. And for EVM related changes, we're going to have a lot of fuzzing. We have the execution specs that Mario is going to talk about. We have fuzzy VM, and we have fuzzy VM and a few other tools also compare how the EVM outputs look across clients. So you want to make sure that you're getting the same result from whichever client you use. And Hive, of course, is great at that. And with the introduction of blobs with 4844, you have a bunch of peer-to-peer level changes. So we're hoping that devnets are our saving grace here, that we're able to send spam a bunch of fuzzy blobs that don't really make sense and see if we can take down the network. Ideally, you never can. And we're trying this new style of chaos testing. I think it's a bit too early to talk about that, but maybe once we're more comfortable about it, we'll also be talking about chaos testing as a different tool set. And then we have engine API changes. So the engine API will be changing with this upgrade, and you have Hive and spec test to cover most of the cases there. Syncing will be slightly changing because now you not only have to sync state, but you also have to sync the blobs for a certain validity window. So we will be bringing back sync test coordinator from our merge testing days, and we'll be using a lot of devnets. So the idea is the public devnet is open for everyone to sync, and hopefully enough people sync and try weird ways of syncing it to find ways that it breaks. And one of the other things we changed this time around was rather than waiting for all the clients to be done with testnets and with shadow forks before we start MEV testing, we also started including relays and started including MEV boost kind of earlier on. It's also integrated into Kurtosis right now, so you can run a local network with MEV boost. So you can have the entire relay workflow there, or you can use Mario's mock MEV tool there, and the mock MEV tool kind of returns what the relay would have anyway. So we're kind of splitting that testing workload into two halves, one half including the relay workflow, one half just for the client teams. And this means we should be able to accelerate the entire MEV world's readiness for the fork rather than kind of waiting for everything to be done and then waiting for that to happen. And we have a bunch of tooling changes. This is probably all under the hood from the perspective of most people. The car doesn't really change, but we had a new engine. So we switched how our Ansible playbooks work. We switched how we spin up all sorts of tooling. So we have Kubernetes for a lot of tooling right now. At least from a workflow perspective, it saves us a lot of time. We no longer have a lot of manual steps that we used to do in the past. We just have like one script that does everything, and you can have a testnet in even faster than what it was before. And along with Kurtosis, we also are able to do scale tests with it because it supports not only a Docker plugin, which is for local testing, it also has Kubernetes plugin. And Barnabas is going to talk a lot more about that one. And our aim is to use both Hive as well as the Kurtosis SDK to add regression tests for issues that we've seen. And the idea is that if clients are not going to stop making releases, and we want to make sure that if we found a bug today, it doesn't show up again in a few months. Typically, this goes in Hive. We want to kind of play around and see if Kurtosis can also help out a little bit in some scenarios. And yeah, for most of these things, we already support doing it for 2 or 3 forks at the same time. We already support doing feature forks, like feature EIPs in parallel at the same time. And with that, I will be handing it over to Mario, and he's going to deep dive into one aspect of testing that he's working on.
Yes, thanks. So I wanted to zoom in a bit on the source of the Hive testing. So we do a lot of functional testing for this fork, a lot of spec-related testing. And the source of all of this test is basically this new execution spec test repository that we have. So looking at a little bit about the history of how EVM was tested before, and basically we had the Ethereum tests repo, which contained a lot of JSON tests that helped testing the EVM changes on each fork by introducing these JSON files with a lot of blocks, a lot of transactions that basically just do executions on the changes that the EIP was introducing. Now we have this new repo that is written entirely in Python. It was a joint effort started by Light Client from the Vega team, and it was followed by the EF testing team. Basically, just to make EVM test Python executable and leverage the power of the Pytest framework to make tests more readable, parameterizable, and also give the test writer more control over the verifications. And this basically means that we know exactly on Python what's happening inside of the execution of the test. So we can more granularly define what we want to test, that is gas costs of the EVM changes and all sorts of details that it was not really possible before because we have not execution power on the JSON source of the files. Yeah, so on the next slide, please. Yeah, this is basically the diagram of how everything is put together. So everything starts with Python source files. So when we are writing Python source files, we take into account the state of the genesis state of a test. And so here we define, for example, the counts, the code, everything that will go into executing these EIP upgrades. So for each EIP upgrade, we have, for example, one special new opcode or one special new header field that we use on the upgrade. So this definition of this function file now gives us the power to create multiple accounts, create multiple balances, and each single account is defined in a manner that you can specifically test what the EIP is basically wanted to test. The code is basically just smart contracts. For example, on some of the EIPs, when there is new opcodes, the smart contract of these accounts at the start, they contain a specific code that exercises this specific new opcode. Or for example, if we have a new precompile, also there's a smart contract that calls into this precompile, saves its output into the state where we can later just verify it. And that's basically the entire functionality of these methods in Python. The great thing about this, of having everything in Python and having Pytest, is that basically we can parameterize. So we can parameterize different types of calling. For example, when we have a precompile, we can parameterize calling with the call opcode, calling with the delegate call opcode, and so on, or doing this call with different amounts of gas or different amount of value inside of the call. And this makes it very easy just to test all the possible combinations that could potentially have something in the implementation that goes wrong. We can catch this with all these parameters. Inside of this same repo, we have basically just the fill command, which is basically it takes the Python method, the Python function, it evaluates what happens inside, and then it uses a set of tools that are required to put together the fixture that is the output, that is the final test. One of these tools that we used to call is Solidity. For example, if we are using Solidity code into our Python test, we call the Solidity compiler and we compile the code, we put it into the smart contract, and then the entire account is finalized. Normally, we don't use Solidity compiler because Solidity support only happens very near to the fork date. So what we do, and this is a great addition to the Python test, is that we have like each opcode has a definition inside of our framework. So instead of writing, for example, bytecode in hexadecimal form, we have now a really nice representation of each opcode inside these Python files. Another tool that we call is a transition tool, which is basically a tool that each of the clients implement. We mainly use the Ethereum implementation, but we can use any, including Nimbus, Nethermind, and Bisu. Sorry, not Nethermind, but Bisu. So what this does, basically, we feed this transition tool with transactions and blocks, and we get the output state. So for example, in the case we are testing a precompile, we feed into this transition tool, we feed the block that contains the transaction that makes a call into the precompile. And then the Ethereum's implementation will tell us, okay, this is the result of the storage that you, with this transaction that called this new precompile that comes in this new EIP. And we get the output, and this goes into the full picture of the test. Yeah, and basically this picture then goes into Hive. So I will talk a little bit on the next slide about that. Yeah, so here's basically the one-to-one relationship of what happens in the Python tests and how we feed this into Hive. Because in Hive, we not only test the EVM, we also test the engine API, which is an important part. In this engine API is operated on every single fork so far. We start with the pre-state, basically, which is what we defined previously in our accounts or smart contracts or our balances and everything. We also define the starting fork of each test. So for example, we can start a test on Shanghai or we can start it on Cancun. The same test, it gets parameterized into every single fork from the introduction point. And also we have some tests that start on one fork and then proceed to operate inside in a few blocks to the next fork. One example is in this fork, we have the blob usage that is included in the header of the blocks. So for that, we use a test where we start on Shanghai, but on block number 10 or timestamp number 5,000 or something, we operate to Cancun. So the kind of test that we do with this is that we test that the starting parameters of the new fork are correct and the client sets the correct parameters. So this is the setup, and this is done on Hive. Once we get this fixture, we get it on Hive, we produce the JSON Genesis file that is basically the input to the client before starting the client. Because Hive starts the client as if it was running in mainnet, basically. And the engine API part is what the consensus client uses to communicate to the client. So for that, we also have the different blocks and the block properties and the transactions. This comes in our fixture, our test fixture, and the way that Hive fits it into the engine API is by using engine new payload. Basically, it fits the entire block just the way that the consensus client would do it on mainnet, and then it expects an execution result. For example, if we have a good block where everything on the EIP is executed and is validated, we expect that the engine API returns us a valid response. Whereas when we also feed invalid blocks into the engine API, we expect that the client correctly rejects this block with an invalidity. And this is something that happens every single time we get a block in mainnet. So this is the same behavior that we are testing here as it was running on mainnet. Only this is very specific blocks that are testing specific functionality in the EIP. Finally, we also have the post state on our tests, on our fixtures, contain storage, balances, and also if any account was destroyed, for example, which is very important for the self-destruct EIP that we have in Cancun. We verify all of that by using the RPC. So basically, when we have finished feeding the block into the client and we set the head to that block, we then proceed to use the RPC to request the balances, request the storages, request the code, and etc. Yeah, this is basically the flow that Hive follows to test the EIP upgrades. So yeah, so I wanted to give an overview of the magnitude of changes that we are testing on Cancun on the EVM specifically. So it's easily, I think, one of the most EVM crowded upgrades that I've seen, that I've tested in the recent years. So we have 5 EIPs that affect the EVM, and all of them contain different qualities, different things that we need to test every single change in all of these EIPs. For example, we have the beacon root in the header, which introduces a new header field. We have new pre-deploy code, which is not a pre-compile. And so we are going to deploy on the contract, and then we are going to use that to update the state in that contract. So this is very different from what we have been doing so far, which is just deploying a pre-compile at the time of the fork. We're going to pre-deploy code into mainnet that we are going to test. So this had a lot of repercussions to the test, because for every single Cancun test on Hive, we had to update the pre-state and take this pre-deploy into consideration. So, and also we also have the first ever system transaction, which is basically something that had never been done before in an upgrade, which is at the start of the block, we're going to have system transactions that come from a special address, and these are going to execute a special code branch into this pre-deployed code. So this is the first for a fork. So we had to test this also. These are going to be made for this specific case, and yeah, it's still testing in progress. Also, changes to the engine API because we have now a new header field. So we have to test all this change, this inclusion of this new field in all our tests. mcopy is EIP 5656 is just mcopy is the new opcode. So this is very similar to what we have been testing in previous forks. It's just a new opcode that copies memory from one place into another. A lot of tests also were made for this. We have EIP's 6780, which is the self-destruct, now becomes the send-all. So this is another first for a fork, which basically upgrades an opcode that was already existing in mainnet and converts its functionality. So before we had self-destruct, and you can self-destruct any contract at any point in time. But now what this different behavior is that we have self-destructing behavior only if the contract was deployed on the same transaction where it is self-destructing. Otherwise, it will be becoming a send-all. It's basically just sending all the ETH into another account without self-destructing. So this came with a lot of nuances that we had to test because there are some caveats to the behavior of self-destruct that were very into the EVM's behavior. So we had to test all of these changes before and after the fork, and also if we were self-destructing in the same transaction or not. We are creating the contract in one block and then executing self-destruct in the next transaction, or a lot of test cases were involved into testing this. And also we have 1153 introduces two new opcodes which have like transient storage inside of the same transaction. So the repercussions is that we have to test multiple calls in the same transaction and see that the storage does not pass on to the next transaction, basically. And yeah, the main event is 4844. I had to just do a whole slide for this because there are so many changes in this EIP. The amount of tests also was very, very important. For example, we have a new precompile, which is the KCG point evaluation. We sourced cryptographic test vectors from the consensus specs. So now basically we are producing automatically generated test cases for this precompile. But we had to test also the EVM factor of it. So for example, we are calling the precompile with different inputs, with different call data from these different addresses. There's a lot of involvement in the parameterization. It comes with this parameterization was very helpful. We did not have this before, so the execution spec test proved to be very helpful in this specific case to generate automatic test vectors. It was really simplified, as in contrast to the way the tests were written before. We also have on this same EIP, we have a new opcode, which is the blob hash. Basically, we obtain information from the transaction with the type 3 transaction, and we also embed that into the opcode. We also have the new transaction type, which is type number 3 for blob transaction. This is a special type of transaction that includes the blobs that the L2s will use for that availability. And there's an important distinction in this transaction type, which is we have now two transaction flavors of the same type. So we have the network flavor, and we have the one that goes into the block. So we had to test. We actually found an issue where one of the clients was embedding the incorrect flavor of this type of transaction into the block, which resulted in an invalid block. So there are a lot of nuances that went into the details when we were implementing the test for this. We also have two new header fields. So it includes the blob gas usage, basically, and the excess gas, the excess blob gas accumulator. This is important because this also affects the pricing of this special new type of transaction. And we have to make sure that every single client respects this new header field increase. And yeah, respect all the modifications to the header field. And yeah, as I mentioned, also new blob gas pricing that went out. There was a lot of consideration in testing in the test cases that we did for this. So basically, it's just a matter of introducing a lot of blobs in one block and then seeing that on the next block, the correct gas for blobs was priced into the transaction and also subtracted from the balances that were sending these transactions. So yeah, a lot of different exotic test cases were written for this. Also, and on top of all of that, also introduces a lot of engine API changes because we have now the version 3, and this has the versioning hashes inside of the engine API endpoint. So there's a lot of testing also. Hive was a very important point for testing this, mainly because on the execution spec test, we don't have a way to reach the engine API, but Hive does. So we had to come up with a new way of writing tests that also introduced changes or definitions of the engine API that Hive could read, so we can test some exotic combinations of these new changes to the endpoint. And yeah, and just for reference, this is roughly the number of EVM tests that we have. This is not everything, but just to get an idea of how many tests per EIP we have, this many tests for all the EVM changes, but also we have the engine API tests, which are written entirely into Hive, embedded into Hive. So these tests are that do not mess a lot with the EVM, but instead, for example, the transaction pool, the block transaction ordering, the versioning, the block building process, and verifying that the client builds a block with the blocks embedded, and that provides all the information from these blocks. Also client peering, the fork ID and all that stuff. It's also tested into Hive. So if anyone wants to take a peek into the tests and to get a better idea of how we parameterize the test and how we created this test, please follow these links here. You will see every single test that we have introduced into Cancun. Yeah, also PRs are welcome. Please go inside, take a look, take a deep dive. If you see anything that you would like to, or maybe just to mess with the test, please go ahead and take a look.
Now I will begin to talk about Kurtosis. So Kurtosis is our next step of testing tool. We've been using Kurtosis for quite a while now, and I will begin with why do we even care about Kurtosis? Why don't we just jump straight to public testnets or a Devnet? So the main benefit is a very fast iteration. So you can spin up a Devnet in under 5 minutes, and all of this testing can be done on your local machine. You don't need to spin up any cloud instance. You don't need someone else's computer to run these tests for you. You can just do it yourself. You can customize also your own local testnet any way you want. You can have 3-second slot times. You can have 20-second slot times. You can run any image you want. You can run any combination of the nodes you want to run. So it's very, very customizable and very, very scalable also. So scalability comes thanks to their support for Kubernetes. So Kubernetes allows you to scale up to a very, very wide range of nodes. So you can run 100 nodes on a cluster of 10 physical nodes. So this enables you to run larger testnets, also run local testnets in a non-persistent way. So you don't need to have a large SSD because all of these tests will be staying on your machine in RAM. And once the testnet is shut down, then all of the data will be just going away. Another benefit is all the clients are supported, so we can test every single client with every other client. And in theory, it should all work. And the configuration for it is very basic. You don't need to have any knowledge about any programming languages. All you need to know is read a configuration file, and you can get started. So here's an example of a configuration file. As I mentioned, it's a very basic JSON file where you will define your EL type, which in this case will be a gas, a CL type lighthouse. So in the first participant will be 2 counts of gas and lighthouse pair. And after that, you will have a nethermind and a techo pair, and that will just create 1 instance. And in the network parameters, you can define when do you want to have a fork epoch, fork capella, or DNAB, and hopefully all the future forks will be also supported. And this JSON file is very customizable. You can set whichever client version you want. You can override memory limits. You can customize resource usage per client. So this enables you to automatically scale up or down your Kubernetes cluster, or just to limit each of the client pairs to a specific resource limit. Here's an example of like how fast it takes to spin up a network. It's actually just looping around. It's a GIF, but it really is as fast as you can see it there. In the next page, you will see kind of the background of the Kurtosis engine and how you can interact with Kurtosis. So there's different methods to interact with the Kurtosis cluster or the Kurtosis engine. And the most standard way is using the CLI. So just run a simple CLI command and it will spin everything up for you. Another way is to write some tests in Go, and then you can interact with the Kurtosis SDK. And then the Kurtosis engine will do the orchestration for you. So you don't have to deal with how the pods or the containers will be deployed to your enclaves. So enclaves are the bodies that will hold all your services and that will communicate with all the nodes that you have created. Here's a couple of examples that we have found using Kurtosis. In the past, I would say 3 weeks, we have found multiple interop issues with Prism, with Nethermine gas. We have found out that one of the Nethermine config was wrong using our Genesis generator. We also find out that Bezu was unable to produce blocks after the Cancun fork, and we found plenty of syncing issues in Aragon. And just today, I managed to find the Bezu overflow for using very large integer for Cancun time. There's a couple of links here that you can find, and yeah, we would like to welcome you if you would like to spin up a local DevNet yourself. So the next step after running a local DevNet on your machine is when we're doing a DevNet where all the client teams will participate and where they can deploy their application, or well, we will deploy their application and we can actually check the interop. So we are currently at the 8th iteration of Dencun DevNets. Yeah, it's been going on for about 8 months at this point. So we're averaging 1 DevNet per month. And this is the first time where we are testing all the Dencun EIPs. So previously it was all about the 4844 because as Mario and Pari mentioned, 4844 is such a massive EIP that we had to make sure that that will work first before everything else comes on board. So this is the first one where we include all the EIPs that Mario went into detail with. And currently, everything looks pretty good. We have a couple of issues on the Prism and Nimbus side on the consensus layer. And on the execution layer, we have some issues with Bezu and Aragon, but I'm sure it will work out. So you can find the spec list and the homepage for Devnet on the links mentioned on this side. Oh, one quick mention about our next public testnet. So Holeski is coming soon. Our launch is now scheduled for the 15th of September, and we hope to see you there.
And we just wanted to mention, we still don't have a name for whatever public Dencun testnet we're going to have. So send us name ideas if you can think of one. And thank you. I think that's all that we prepared. And if you guys have questions, we're happy to take them now.
That is awesome. Thank you, Pari, for high-level overview of the evolution of testing upgrades and tools those are being used. Mario, for hype testing on execution layer. It was really interesting to know about 1559 like gas pricing and type 3 blob transaction type. I believe people who are not closely following 4844 calls, they may be interested in learning more about what it is and how blobs are handling all those things. Those were earlier handled by blocks. And I was like amazed. So see like over 1,000 EVM tests. Kudos to your team. And thank you, Barnabas, for explaining Kurtosis. I really love the icon that you guys have used for Cancun, the small tree and everything giving a beach look, and it was a nice addition. I would encourage people here on the call, if they have any question, you can perhaps add in the chat so we can invite you to take your question. In the meantime, I have a few questions from the presentation that we have today. I'm just a little curious about the testing sequence. We learned that team are trying to launch the DevNet only after the spec is passing the Hive test. So what are the sequence for the other, like attack nets and shadow fork? Are they work in parallel or they are after DevNet and before public testnet?
So typically we'd want to keep that after DevNets and before public testnets, but there will be some overlap. For example, we tend to use Marius's transaction fuzzer, for example, to attack a lot of our DevNets, but that also is already built into Kurtosis. So there is some overlap, We don't keep a strict sequencing, but yeah, ideally we would move on to the attack net phase once the devnets are stable.
And regarding shadow forks, we already had a shadow fork for Sepolia, just I think last month. So
exactly,
it's also a bit all over.
It's also a bit all over the place. I think the best way to think about it is anything that needs high coordination, we try to push towards the end once we're more confident. Anything that needs low coordination, something that 1-2 people plus client teams can get together and knock out, that we try to move that earlier on.
That makes a lot of sense. Another important thing that we noticed here today was the engagement of all EIPs. I remember it was mentioned in one of the dev calls that the DevNet 8 will be full-featured DevNet. That means it will include all the EIPs. Those are getting into the Dencun upgrade. Though the list misses 2 of the EIP, 7044 and 7045, which I believe are on the consensus layer and not on the execution side. So don't we want to test that, or they are so simple that it is okay to be included directly?
I guess I can respond that. I think most of the consensus specs, they contain this test for that specific change. So we didn't go into detail of how the consensus changes are tested, but the tests are isolated in the consensus spec, basically. So these EVM changes are constrained to the execution specs repo that we have. But the consensus EIPs are normally tested on the consensus specs.
So is there any vision to maybe have a full EIPs included in any of the DevNet before the launch of the public testnet? Because I see there is already inclusion of engine API, which is not coming up with its own EIP, but still it is a part of the present DevNet.
Yeah, we definitely will be including everything before. I'm sure there'll be a DevNet 9 before we'll go on to a public testnet. The question is just when we do the change from DevNet 8 to DevNet 9. I think in the past, the answer was a bit easier because DevNets would break faster. I think now that we've moved a lot of testing earlier to the cycle, we need more difficult bugs to break them. So we still haven't found our rhythm there.
That is good to know. I understand that things are getting complicated, and I must agree now, like we had chat with almost every author of all the proposals. Those are getting into this Dencun upgrade. But when I'm looking at it from a bird's eye view and considering the testing effort that you guys are putting in, I must have to congratulate you guys. It's really different from all other upgrades that happened in the past. So kudos to the team here. Talking about the public testnet, when do we think that we can move on to the public testnet? And if we do, will it be Sepolia or just the Holeski?
Well, for now, we've been focusing on the Holeski launch. There's a Twitter thread, at least from Barnabas and I, as to why that took so long. It's that clear case of one Monday morning, we're like, oh yeah, this must be easy to test. Let's try it out before we announce Holeski. And then 2 weeks later, we still hadn't finished testing it because we wanted to find out how many validators the beacon chain can handle. And that's a big problem in itself, which we underestimated. So now we're playing kind of catch up on Cancun testing. And once we're done with this, we would start planning the next public Cancun testnet. But I don't think we have anything to announce today on that topic. We would first want like the kiln style public testnet that would go along for roughly a month. And if we like the stability there, then we would propose to fork Holesky first. That's at least my personal opinion. I don't know if ACD would agree with that, because Holesky would have such a large validator set that if that large validator set is able to handle blobs flawlessly, that introduces a ton of confidence. But I know in the past we've done it the other way around as well. So we do the simplest testnet first, and then we do the most difficult testnet last. So let's see. There's also one extra issue or point we have to figure out. Currently, all the devnets work with the assumption that we have three blobs and then 6 maximum. We don't know if this is the value we're going to go with mainnet or not. So we're trying to do extensive testing. But the issue is that most of the tests we're doing don't really teach us if mainnet will be fine with this size or not. So one potential option is, since Goerli has been deprecated, to fork Goerli first with 3.6, see how Goerli reacts. If it fails, well, it's a deprecated testnet and we know not to do that on mainnet. If it succeeds, then we learn a lot about how it succeeded, what implications the success had. Did it reduce increase block proposal latencies? Did it increase the amount of time that the attestations take to propagate and so on? And we have a bunch of visibility tools, peer-to-peer visibility tools right now that help us gather this information. So it could be that Goerli happens first.
So just out of curiosity here, I remember when I had a chat with Terence about 4844 initially, then we were in a position to have 2 and 4, like 2 blocks per block and kind of 4. But later on, when talking to Gajendra Singh, it went to 3 and 6. Now that we are talking about testing here, and we just discussed that there could be a possibility of breaking it. So if it does break, where are we going? Going back to 2.4, or we are thinking of something different?
I think it would definitely depend on how bad it breaks, but I would guess we then go down to 2.4 would be my guess there.
And we can still go down to 1 and 2. So that's like
Exactly. And I think there's also a stream of thought where people suggest, why don't we just do 2.4 to begin with? We know it's kind of safe, and then upgrade to 3.6 later on. But then the contra is you're leaving some scalability on the table for a few months at least. And even if it's a minor change, we would have to test everything for the next fork. So it will add some complexity for testing down the line.
That makes a lot of sense. And I have a question with respect to the Pi execution spec thing. So I'm curious, like, where are we with the testing? Like, are we ready with the latest upgrade? Will it be like, Cancun ready, or we are still behind Cancun and we still need a catch up there?
Yeah, I have to say that it's continuously, it's never done. We have to, every time you can think of a new scenario, new edge case, it comes a new test. And so we are trying to do the best way that we can to fully test the spec, but we continue adding tests daily. I think one of the main difference I think that's going to happen between now and the actual mainnet is, well, 2 things. Is the 4788 contains the pre-deploy that's going to have to be updated because we are going to deploy bytecode into mainnet. So there's going to be an audit on that bytecode. So that's possibly going to change. And so when that changes, we have to update the test. But this is now really easy because the Python test makes everything so parameterizable so easy. It's not a big deal. The other thing that's probably going to impact also the tests from the difference between now and mainnet is the trusted setup. For 4844, we now have like this not secure version in the testnets, but on mainnet we are preparing the ceremony that will contain the final trusted setup. So that's going to be another very important change that we are going to have to refill all the tests and redeploy and recheck with every client that they follow this new version of the tests.
So we kind of have the exact same problem on the testnet testing world as well. Our solution was also pretty similar. So we have this fancy big Docker container tool that shoves every tool into one nice to use script. It's just called Ethereum Genesis Generator. And then we added the bytecode there as well as the trusted setup file at that level. So even from our perspective, changing it is changing it out in the root tool and then making a release. And then everything else will just inherit it from there.
Yeah, we're definitely in a much better spot testing-wise everywhere. We are making everything more modular, more automated, more parameterizable, and very easy with the spec changes. With the last month or so, there were a lot of spec changes that affected basically all the tests. And if we didn't have, for example, the execution spec test, the Python test, it would have been a much bigger effort. I mean, we could talk about several weeks of just trying to modify everything, but now it's become a little bit more manageable because we have this parameterizable, more code-based approach onto testing.
Thank you. I see Lion has a question here.
Hey, so personally, I just want to first praise the entire DevOps team, which are rock stars, and they have been doing an amazing job like for real. But the counterpoint is so many members of the community and also protocol devs share this frustration where it seems that forks move so slowly. And I guess I want to, on one hand, if you can justify the slowness, and if you can see something that we can do in the future to hopefully move faster.
Who wants to take that? The
we could
Barnabas and the
remove the
spicy
number-
take.
You could possibly remove some of the client teams, and then we wouldn't need to check for interop. But then we remove client diversity. So you either you win some and you lose some. So if you want client diversity, then it will take a lot of interop and a lot of time to move forward. If we would have a single EL and a single CL, I think all of these tests would become fraction of the time, and we wouldn't have nowhere near as much problems as we face right now. Also,
But
lots
that's
of bugs would
definitely
probably
not
not be
something
caught.
we want to support. That's up. Yeah, exactly. We wouldn't be able to catch a lot of bugs, and it's definitely not something we want to support. I think one thing we're trying to make far simpler is running local testnets, and that's exactly for the optimization that, for example, if someone's working on a new EIP, they're able to already implement the EIP on more than one client, as well as test interop in more than one client before we even consider it for inclusion on mainnet. And that means that you've approached the EIP change list from not just the perspective of one client, but multiple. And that already takes care of a lot of edge cases, bugs, etc., which means by the time it lands up on the testing table, it's mostly going to work. And a lot of clients would already have like a reference implementation and make it more featureful. So maybe that stuff all helps. I can tell you, for one, we haven't slowed down any sort of testing on Verkle, for example. As far as I know, the EOF guys are coming up with a specification that's more or less complete, and then they'll have a bunch of implementations to test as well. So rather than doing more sequential forks, we're kind of spending some time now to do parallel forks so that we can achieve more later on, like in quicker succession than we did right now, hopefully.
One more comment on this is Kurtosis is able to help us test things. So in an ideal world where Kurtosis is fully fledged, we're going to be able to write full-fledged tests in Go, let's say, put it in a CI, and every client could run it on every PR, let's say, that CI job, and it would be able to test the latest PRs for each client with the latest of every other branch. So that would be the ideal world where we don't have to test, but all the client teams would be able to test locally before we even go into Devnet.
Yeah, and from the specs test, I think one of the most the time-consuming task is updating all the tools that we use to generate and to run tests. So what I personally want to see us focusing on the future forks is that we don't depend as much on these external tools, and we are more coupled with the specifications. For example, execution APIs. Every time that we have a new directive or endpoint in the engine API, we have to upgrade several tools or wait until, for example, Ethereum implements the changes into the engine API. What I would personally want to focus on is just skipping that part and just going directly and pull all the changes from the specs repository, making everything a shorter length of deployment of the test, I would say.
Yeah, I guess you can consider it that we're kind of paying back a lot of tech debt right now. I think both the testing team and the DevOps team also has new people who came on board to help out with getting more things done. I already feel bad when I have to ask Mario if he can update one of 10 tools that he's maintaining that we end up using on testing, as well as doing a lot of the testing. So I think now we have more manpower to also do more things faster, hopefully.
Automation is the future.
Exactly. Hopefully that somewhat answers your question there, Plan.
I hope it does. All right. I really remember about the era when we were thinking of having a schedule of network upgrade. It was blocked mostly because we were having issues with testing. And now that upgrades are being tested in parallel, we are getting ready for like future feature upgrade. I think it's going to make it faster. We can see perhaps 2 or more than 2 upgrades in a year. So that's great. My next question is about participation on the testnet. I understand even with Holeski and for any of the public testnet, you may be looking for validators to join in. There could be a set of pre-validated validators who would be joining the network for testing. But I'm curious to learn about solo validators. Do we have thoughts about them? And if there would be any kind of documentation made available for them to participate in the network?
Yeah, definitely. So right now with the Genesis state, I don't think we have any individual validators on that. We have individuals who are running many validators, but the main reason for that is with 1.4 million validators, 1.4 million and one validator is not changing anything, but it adds a ton of coordination effort on our side. So instead, our focus was on making Ether really available, making Ether available to the people who know how to distribute it really well, for example, ETHStaker, and a bunch of faucets, for example, the proof of work faucet, and there's a few other faucets in the list. And the idea is that once Genesis has happened and we can ensure a stable set, any solo validator will very easily be able to go and get Ether and make deposits and test the entire workflow. We're also already in touch with the Launchpad team, so there will be a Launchpad set up. It will be updated in the staking deposit CLI. So pretty much any guide you had for Goerli, ideally you can find and replace, change Goerli to Holeski, and then you should be good to go.
That is great to know. I have recently had conversation with a couple of staking projects. Those are coming up, and at present they are testing their project on Goerli testnet. How far in future do we see Goerli around? Is there a recommendation or maybe a switch instruction from Goerli to any other testnet that is going to be supported for a longer term by the DevOps and testing team?
So if you were to go to the ETH client/Goerli GitHub repository, there's a deprecation notice already active there. We would suggest at the latest, once Holeski has Genesis, people stop deploying new things on there and focus on moving to Holeski as soon as possible. As far as I can tell, probably Dencun is going to be the last upgrade Goerli will get. And then afterwards, if people want to exit their validators, they're free to. If someone wants to continue validating on Goerli, they're free to. If someone wants to coordinate upgrades on Goerli, it's up to them. It just won't be an officially supported testnet.
That makes sense. Thank you. My next question is about any success story or roadblocker that has delayed the upgrade a lot from the testing perspective that you would like to share with the community.
Do you guys have something?
I'd say that they're having more spec changes recently than in any other fork. Personally, for me, that was one of the, because you have to not only understand the changes, you have to also prepare the changes to the test and also deploy the test and also run them again all together. But I would say it was not as bad because we were more prepared in this time. But yeah, if I have to say something, probably would be that. But it's not it was not a big deal in my opinion.
That's definitely true. I mean, there's this in the past we never had a spec coordination document, but Barnabas found it extremely useful to have a spec coordination document that states the status of a PR. So it also has open PRs, merged PRs, closed. That tells you as to how many changes that were happening and how difficult it was to coordinate those changes as well. And also huge kudos to Barnabas for maintaining that list. I tried maintaining it for a while and was very quickly overwhelmed.
Yeah, I just linked you the document. You can see I started writing the docs for Devnet 6 and onwards, because in the beginning for like Devnet 5 and Devnet 4, it was just way too many changes at that point. So at Devnet
Also,
6, I was hoping that it's going to be all finalized at that point, but clearly not.
And we got some great feedback from client teams that they appreciate having a sheet where they can just reference, okay, do I need this EIP in, or do I need this commit to join this testnet or not? And that drastically reduces the number of, oh, I just had the wrong version deployed and we just wasted some time deploying a testnet.
Right. Documentations, checklists, these are great tools for coordination. And it's great that we are having. I do not have a recollection. Did we have Devnet up till version 8 before this for any earlier upgrade? So yeah, I can understand how many, how many times specs might have been changed for you guys. But
there were also different people taking care of different devnets this time. I think we had Infi from Optimism taking care of 1, 2, 3, or 1, 2, 3, and 4. And we had Raphael and Sam taking care of 5, I would guess. And then Barnabas and me taking care of 6, 7, 8. Yeah.
6.1, 6.2, 6.3, 6.4. Because I think I relaunched 6 at least 5 times.
Yeah, so we also got the feedback to not relaunch testnets and just bump the number.
But then we would be at like 14 at this point, I think.
Yeah. But that's also why we wanted to have the local testnet so adamantly, and we wanted to enforce this sort of Hive paradigm so adamantly, because we can avoid relaunches. Exactly.
Right, but having it based on months, that is also helpful, right? It's at least give a sense like how long this upgrade has been in testing.
So we started in January, I think. That's when they were even a bit before that.
Yeah, I think Infi already had 1 and 2 at least before January.
So with all these testnets in mind and future testnet that you guys are predicting, I think there was a mention of having a kind of testnet for a month, and then there would be Holeski and everything. Just an estimate. When do you think we can have Dencun on the mainnet?
I think that's always the hard question. I think my answer is going to be end of the year or beginning of next year is a very realistic option. Honestly, depends on what we find. But for now, testing is, I'm actually very impressed with how stable Devnet 8 has been. It's been live for over a week, and I kind of forgot it's been live already, which is great news for a Devnet, because we have alerts turned on, and if it's broken, then we get alerted. So we're moving in a good direction, at least.
So it's not launched during the Dev Connect in November.
Ooh. Maybe someone wants to take a contra position there.
Very well. So I know it was an interesting conversation and we went a little over time, but just to wrap up this conversation, any of you have any messages for the Ethereum community, the validators community, or people who are interested in testing and making contribution?
Come check out Kurtosis.
Yeah, come check out Kurtosis, come check out Hive, execution tests. We all welcome PRs everywhere. We're happy to onboard you on the testing stack if you're truly interested. And please take part in Holeski. Keep an eye out, migrate your validators from Goerli to Holeski. Yeah, just get involved. And we need a new name for the testnet, so reach out.
And a hashtag.
Yeah, testing the surge is a hashtag. We're okay there.
Okay, that is cool. Very well. Pari, Mario, Barnabas, we thank you for joining us on PEEPanEIP and talking about Dencun testing updates. We look forward to seeing tested proposals on the mainnet with Dencun, perhaps by the end of this year. And on this note, thank you to all our YouTube viewers for watching and podcast subscriber to listen to this special episode. Should you have any question on this or any other topic, let us know at @Discord. Check out the description for more information, for links to other proposals that we have discussed in this series, which are getting into Dencun upgrade. We'll be back with another interesting talk. Until next time, keep watching, keep listening, and keep sharing your love with Ethereum cat herders. Cheers.